So good morning everybody. Today I will start the topic desalination. So desalination is important part here for your offshore applications. For example, ship or offshore platform, you need desalinated water. So long back there was one rhyme: water, water everywhere, no any drop to drink. So that means like water is there, but you cannot drink actually. It's so much salty. So if you drink, actually you can die. So you have to reduce amount of salt content from your water. So not only salt, if any bacteria or any other contaminant is there, you have to remove that one, then you can drink or you can use for other purposes. So for your ship applications, offshore platforms applications, there will be maybe boiler systems. So boiler system needs actually desalinated water, or no iron or no salt or no minerals should be there in water. So that water will be used for your boiler application. If you are having that content, mineral content or salt content, so that will be getting deposited in your boiler pipes, and finally it will fail. Okay, so whenever you are giving feed water, that makeup water will be coming from your desalination system or filtration system. Now there will be a requirement of water for cargo ships or any type of ships or passenger ships or recreational ships, but offshore platforms like oil platforms are there, so they also need water because engineers will be working for 15 days on off, oil industry cases. So in that case also they need huge amount of water for their consumption, for drinking purpose, as well as for day-to-day utilization, for cooking purpose, for bathing purpose, for many other purposes. Okay, so when you are talking about desalination, so previous days people are used to carry water when they are traveling, but now you have desalination system, so people are using the new techniques, desalination using thermal or membrane systems. So membrane system, you already know that reverse osmosis based system, it will be domestic that water purifier. So AquaGuard or many other companies are supplying that water purifier. They are having RO based system, reverse osmosis. Okay, reverse osmosis based system. But some cases like bigger unit, if you have, then thermal desalination system also possible, or low temperature you create and low pressure you create, and you can create more vapor. Again you condense the vapor, so that way you can get desalinated water. Even these days in desert area also, people are getting desalinated water, actually filtrate, because they are reducing temperature such a low temperature that whatever moisture is there in air, so that air moisture will be condensed, it will be collected in a pot. Okay, so in desert area also you can get water because of modern technologies. Now in a desalination system, there will be feed water, but the feed water can come from your sea water, maybe it will be groundwater or maybe brackish water. Whatever water you get, you can purify. Okay, so now all water is not same in terms of desalination, because sea water is having larger amount of salt, but your groundwater, normal river water, they will have lesser amount of salt. So lesser amount of salt means purifying it will take lesser amount of energy. But if you have very large number of salt, like say amount of salt, let's say sea water 35,000 or 36,000 ppm, parts per million, so in that case your energy requirement will be very high. Okay, and when you desalinate, you will get two product. One will be fresh water for drink or other purposes, and will be reject brine. So this will be having higher salt content, higher salt concentration. Okay, and this one potable water, you can make potable or other uses. Okay, so all your ongoing ship, cargo ships for long distance or short distance, doesn't matter, you must have water source there. Okay, and all the content I have taken from basically different website sources I have collected, and I made this slide because you don't have too much time to allocate for this course, for this desalination part in your course. So I have collected different portion which will be easy to understand for you, so that much content I have given. So seawater salt content, you can see chloride is the maximum portion. Okay, so seawater salinity will be 36,000 ppm, parts per million, right? And majority is sodium chloride, actually sodium and chloride, you can see. Okay, and there will be some other salts also. So whenever you are desalinating, you have to remove all the salts, and you have to reduce your water salt concentration about 500 ppm. Okay, so 36,000 ppm to 500 ppm you have to bring down. In IT campus also, you are getting water about 500 ppm for your potable or tap water, whatever is coming, it will be around 500 ppm. And if you have more than 500 ppm, let's say 1000 or more, maybe you can use for clothing and other washing purposes. But for potable drinking purposes, 500 ppm okay. But if you are having very low salt concentration, then there will be very much mineral shortage. So that also not suggested actually. Many scientists says no, don't remove completely the mineral part, because it is required for your health also. But too much mineral also not good for your health. So salt water about 35,000 ppm, 35,000, 36,000 within that range. But normally sea water or river water, that will be having 1,000, 1,500, that much, or maybe less also. As a groundwater taking, that salt concentration will be much lower also. Okay. Energy consumption will be very high if you are desalinating sea water, because larger amount of salt is there, so it will take more energy to reduce 35,000 to 500, 600 ppm. Okay. Desalination process, there will be two methods basically, thermal process and will be membrane based or RO based system. Okay, and 2018 there was 18,000 desalination plant operating 150 countries, producing 687 million cubic meters of water. And many people think so that in next world war will start because of this potable drinking water shortage. Okay, many people predicts. So 300 million people are getting water. Energy requirement 20 to 30 kilowatt hour per meter cube, 1970 to 3 kilowatt per meter cube. So the technology improving, so amount of water energy requirement to produce certain amount of water is reduced. Okay, and you see this 2018 data 18,000. Now day by day the number of plants increasing, and major plants are there, especially in Middle East, where dry countries are there. They have lots of money also, so they can install lots of desalination plant. So especially Middle East, Qatar, Kuwait, all Saudi Arabia, they are having large number of desalination plants. Now if we consider one ROB system like you take seawater first, then you remove sand content, then any scaling or any deposition is there, you have to do this anti-scaling dosing, then cartridge filtering, then one pump will be there. So the pump will be pressurizing water, the seawater, about 60 bar pressure you have to create. Then only your salt water will be passing through membrane, and you will get distilled low salt concentration water. Okay, that is called permeate. Then after membrane, whatever you are getting, one is getting permeate, another is getting reject. Okay, reject means the high salt concentration part. So that one you are not using, you are throwing in the ocean again. Okay, so the several process there. If you open any domestic your air purification system also, they will have several system actually. There will be some sand filter, there will be carbon filtration, there will be UV, there will be many techniques are there. So one bacteria killing will be there, odor or any smell is there, so that removal, charcoal filter will be there. Then your RO filter will be there, candle, this is a candle actually, this membrane, and this is a candle. Okay, so shape will be like this, cylindrical shape. Okay, they'll be putting, and water will be entering one side and it will be exiting from other side, and it will be removing all the salts, and it will be reducing salt concentration to about 500. So if you see any RO plant, first we are considering RO, reverse osmosis plant. So it will have few different components. You can see this previous slide, like you have seawater intake, then sand filtration, scaling. So all the things in short we'll discuss. Okay, so feed water, a feed pump works. Seawater passes through strainer, the pump backwash the sand filter. RO plant operates more than 4 nautical mile away from the shoreline, because nearby shoreline there will be lots of debris and contaminant. So just to avoid that one, a few miles away they will take water and they will be purifying. Okay, they can take water from contaminated area also, but problem is that all the mechanical equipment will be getting clogged. Okay, that will be increasing your desalination cost finally, because you have to remove all this filters and you have to replace with a new one, or you have to clean, right? Just to avoid that one, just they will take water from mid side of the ocean instead of coastal side. So there will be next sand filtration. So it will be removing large suspended solids. So very small suspended solids will be captured by your other filters, but sand filters, like little bit larger particle, they will be captured. Okay, so and sand filter sometime backwashing will be there, opposite way there will be flowing water, and they will be cleaning the sand filtration system. Then there will be anti-scaling dosing. So anti-scaling dosing refers to applying anti-scalant chemical actually to prevent the formation and precipitation of mineral salt that cause scaling. So scaling means rusting or deposition of metals oxides inside the systems. So if it is getting deposited gradually, the whole pipeline system or your filtration system will be getting blocked. So that's why you should put some anti-scalant dosing or some chemical to avoid scaling. So anti-scalants are typically proprietary organic polymers such as polyacrylic, carboxylic, polymalic acid with molecular weight range 2000 to 10,000 Dalton. Seawater contains springly soluble salt like calcium, barium, many other salts will be there. So that salt should not create any scaling. So that is the purpose to make this anti-scaling dosing. And now next will be pre-treatment feed. So initially you got feed water, then you remove bigger contaminant debris are there, sand removed, anti-scaling dosing you have done. Now again pre-treated feed water, you have to do pre-treating. So large suspended solids with anti-scalant gun. Now cartridge filtration. So one more level of filtration will be there, that is called cartridge filtration. Okay. So after that there will be pump. High pressure pump should not get all this contaminant, because high pressure pump, if they are getting contaminant, it will get blocked or clogged. Okay. So pump is the main part of your system. A pump will be giving pressure about 60 bar for seawater desalination, but for other water desalination pressure requirement will be lower. So higher pressure means higher energy consumption. Okay. So 35,000 ppm water you are taking and 60 bar pressure you are creating, then you are getting filtration, I mean pure water or potable water. Okay. So here they are saying 225 to 375 psi pressure will be created required for brackish water, 800 to 1180 psi for seawater. Okay. So to achieve such high pressure, one okay, here axial piston pump normally it will be used. Axial piston pump, you can remember pump lecture. So axial pump means axial pump, this is high pressure low flow rate. Okay, because in this case 60 bar pressure is required. So normal centrifugal pump if you are taking, then maybe you have to create multiple stages. So multiple stages, maybe it will be more complex actually. So to avoid that one, they will be taking axial piston pump, the reciprocating pump. Okay, you can remember. Okay, so reciprocating pump will be moving, piston moving up and down, and it will be delivering, and it will be delivering at very high pressure. But axial piston pump property is that it will be delivering at lower flow rate. Okay, but centrifugal pump, if you are using, centrifugal pump will be giving higher flow rate, but pressure will be lower. So in that will be difficult to handle, because then again space consumption, the total space requirement will be larger. Okay, so small amount of fluid you are pumping at higher pressure, then positive displacement pump. These are called positive displacement pump. Positive displacement pump. Okay, so positive displacement pumps are there: axial pump, diaphragm pump, scroll pump. So several other types of pumps also there. Okay, progressive cavity pump is there, screw pump is there. Okay, so normally piston pump is very common, because very simple in construction, like injection syringe, taking certain fluid and delivering. Okay. Now reverse osmosis, when you are talking about, then you should know what is osmosis first. So osmosis, when a semi-permeable membrane separates two solution of different concentration. So you can see this one semi-permeable membrane in picture. Okay, and this is dilute solution and this is concentrated. Okay, this is concentrated solution. The dilute solution will be passing the membrane, it will be going to concentrated solution, and the pressure, this height will be larger than this height. Okay, if this is H1, this H2, so H2 will be larger than H1, okay, because of this semi-permeable membrane. So this actually, this technology is used for your one ocean energy conversion system. So okay, so because you got higher head here, this water you collect and you pass through this one through a pump or a turbine. Okay, so if you can pass through this turbine, you can get some electricity actually. So then how you get this salt different or the different concentrated water? River water will have low salt concentration, sea water have high salt concentration. Now when river is meeting ocean, you put one membrane and you create certain structure like this, so that where seawater side is there, so their level will be increasing, and river side water level will be lower. So higher level when you got, you put that water through one pipe, one turbine, you get electricity. Okay, so that technology also people are trying to develop from seawater to energy. Okay, because river salt concentration is lower, seawater salt concentration is higher. So two salt concentration when you are mixing in and salt concentration water having a membrane inside, one higher level and a lower level, you are getting energy. Okay, so this phenomena is happening because of osmosis process. This is called osmosis. So this is called semi-permeable membrane. The term semi-permeable means it will be allowing certain amount of salt or fluid to restrict, certain amount to allow. Okay, so this process, okay, you see this one, water moves from less concentration solution to the more concentration solution. This process continues until the concentrated solution is equalized on both side membrane. So continuously this low density fluid will be moving, water will be moving through this one. Okay, the direction and quantity of fluid are determined by chemical potential influenced by pressure, temperature and concentration of the dissolved solids. So role of osmotic pressures: as water flows from the less concentration to the more concentration solution, a net pressure is created due to the static head difference. Okay, so you can see this is the net pressure. Okay, so H rho g, you can calculate how much pressure is created. Equilibrium is reached when the osmotic pressure prevents further fluid flow across. So this H rho g, it will be increasing after a certain time, that pressure will be forcing back. So that's why there will be some equilibrium in between. So then reverse osmosis will be opposite. How it is happening? A pressurized and more concentrated solution is passed through a membrane. So now we have membrane, we have concentrated solution, we have diluted solution, a low concentration solution, diluted. Okay, so in this case concentrated solution will be passing certain amount of fluid to diluted solution. Okay, so this is maybe sea water, and you create very high pressure. So at high pressure the salts NaCl, all the salts will not move through this membrane, only water will be flowing through this one. So only certain amount of salt may be going based on your separation, your membrane efficiency. This process blocks particles, bacteria, large organic molecule through molecular filtering, and ionic repulsion occurs when only water can pass through the semi-permeable membrane while dissolved molecules are rejected. Okay, so salt, whatever salt is there, that will be rejected by this membrane. Okay, and this salt seawater side concentration gradually be increasing, because water part going to diluted section, but salt part is remaining. Okay, so this part will have more salt concentration, so gradually the salt concentration will be increasing. So you have to remove that also to increase your system performance. Okay, the semi-permeable membrane has a high rejection rate for multi-charged ion like calcium, sulfate. The reject rate exceeding 99%. Reject rate means the water you are rejecting. Okay, The water produced through this process is called permeate. So, whatever water you got, permeate, permeate, and whatever rejected fluid, it will have high salt concentration. High salt concentration will be there, and how much higher than the actual ocean water whatever you used. Okay. So, however, until the water is treated with the required parts per million of chlorine, and pH also should be maintained. Whenever desalinating, pH you have to maintain. You have to remove bacteria, you have to remove salt, then only you can use for your shipping applications. Okay, here one picture of semi-permeable membrane or candle, you can say in domestic, that water purifier, AquaGuard, or many companies are there. So, they will be saying candle. Okay. So, candle means you are giving feed water, okay, and feed water will be going through this all these layers. Then inside here you can see lots of holes are there. You are collecting pure water here. So, you are collecting pure water here. Okay. And your reject is going here, the rejected water. Okay. So, it is flowing through several layers of your membrane, then you are getting water. Okay. So, RO membranes commonly exhibit removal efficiency ranging 90% to 99% for contaminant like total dissolved solid. So, that solid they say total dissolved or TDS. Normally the technical person when they will be coming for servicing, they say, sir, what is the TDS? Okay. So, they say total dissolved solid, how much is there? Now, what is semi-permeable membrane? So, semi-permeable membrane or selectively permeable membrane, they say a membrane capable of permitting passing certain substance while hindering others. Okay. So, water they are allowing, but salt not allowing. That's why this is semi-permeable. This property of selective permeability is determined by factors such as molecular size, charge, and other intrinsic properties. In process like osmosis and reverse osmosis, semi-permeable membrane allows passage of water molecules while impeding the solids. Okay, so here one picture I have copied from this company.